Like we are discussing in the previous lecture, we can't use the authorization code grant flow exactly like we discussed for the public facing clients like single page applications, web applications, native applications, because they can't store the client secret anywhere. The reason is anyone can decompile and check the source code of these applications easily with the help of browser and other tools that we have available. So for these public facing clients, we have a different flavor of authorization code flow. It will work exactly like authorization code flow, but instead of using client secret, we use a mechanism PKCE, which means proof key for code exchange. So there are very minor difference between PKCE authorization code flow and normal authorization code grant flow that we discussed previously. So PKCE enhanced authorized code flow will use the following step. The very first one is when user click login, client app creates a cryptographically random code verifier, like it will generate a random value by leveraging some encryption algorithm. We call that random value as code verifier. And from this random value, it will again generate a different value called code challenge. So during the first interaction with the authorization server, my client application will only share the code challenge, but it will not share the randomly generated code verifier, because using code verifier only you can validate a code challenge is valid or not. So my code verifier is indirectly acting as a client secret instead of having a dedicated client secret that will remain always same. In this approach, my client application will generate every time a random code verifier. So once my code challenge is passed to the authorization server and my user will enter his credentials, and if his credentials are correct and proper, my authorization server stores the code challenge that's shared by my client application and redirect the user along with the authorization code. Once my client app receives the authorization code, this time when it's trying to get an access token from the KeyCloak server or any auth server, along with the authorization code, it will also pass the code verifier that it initially generated in the step 1. Now my KeyCloak server will try to check the validity of my code challenge by using the code verifier, which is the key for all these cryptographic operation. So with the help of my code verifier, if my KeyCloak server is able to matches the code challenge provided, then my KeyCloak server or auth server will return with an access token. So this way, indirectly, without the need of dedicated client secret, client web applications, they can maintain the authorization code grant flow using the PKCE method approach. The reason why we have to incorporate code verifier and code challenge is, suppose a hacker trying to intercept the request after we receive the authorization code. So if we try to send the authorization code to the KeyCloak server to get an access token, he needs the originally generated code verified, which is being stored on the local storage or browser cookie on the client web application. And that really my hacker don't know what is that random value. So due to that reason, the authorization code will be useless for him. Only the application which originally invokes the KeyCloak server API to get an authorization code, it can only try to get an access token by passing a code verifier. Any other persons who are trying to intercept in between, they can't get any value from the KeyCloak server because they don't have original code verifier for the code challenge that was initially shared to the KeyCloak server. So this is the representation of the OAuth to code flow with the PKCE method. So as you know, first user will let public client that I want to access my resource server. So my client application will try to pass the code challenge and my auth server will show a login page to the user. After user enter his credentials and if it is a valid, my auth server will return a authorization code. So now In the fifth step, when I'm trying to get an access token, my client application along with the authorization code, it should also pass the code verifier that it initially generated at the step 3. So if my code verifier and code challenge, they both are matching with each other, then only my authorization server will give access token to the user. So this way we can implement authorization code grant flow without the need of maintaining client secret inside our UI web applications. Thank you, and I'll see you in the next lecture. Bye.